Good morning, good afternoon, and good evening. This is a talk on the Web 7.0 Ecosystems of Ecosystems, Decentralized Digital Governance Model, or DDGM. It's a re-recording of the original talk that was given at the Internet Identity Workshop, IIW 36 on the third day, entitled Web 7.0 Trust Ecosystem Frameworks. In addition to being a deep dive into the Web 7.0 Decentralized Digital Governance Model and the Web 7.0 Trust Ecosystem Framework, it also features a number of interesting applications, extended applications of DID document technologies. My name is Michael Herman. I'm the founder and chief architect at the Web 7.0 Foundation. What is Web 7.0? Web 7.0 is a secure, message-based, decentralized operating system. The Web 7.0 decentralized operating system underpins a unified software and hardware ecosystem for building resilient, trusted, decentralized systems using decentralized identifiers, DIDComm agents, and verifiable credentials. The Web 7.0 Foundation, a federally incorporated Canadian nonprofit organization, is chartered to support, promote, protect, and curate the Web 7.0 ecosystem. That is, it's responsible for looking after the operating system software, the standards and specifications for Web 7.0, as well as other technology and software projects. Web 7.0 and the Web 7.0 Foundation are modeled after the development of the Linux operating system. The Web 7.0 Foundation is the first standards developing organization and standard setting organization to support, promote, protect, curate, and deliver an end-to-end software platform, an operating system for the Internet. I'd like to thank everybody who attended the Internet Identity Workshop Day 3 talk on the Web 7.0 Trust Ecosystem Framework. It was a very interactive discussion with lots of feedback and input received, and it's much appreciated. A special thank you to Marcus at Danube Technology for his vision and commitment to DID resolution specification and the application and use of DID documents, his overall expertise in decentralized ecosystem technologies, and his valued feedback on this talk, on the original version of this talk. So the agenda is really broken into three pieces with an appendix at the end. The first section, we're going to talk about representing arbitrary collections of typed relationships using DID documents. This talk ended up being somewhat circular in the sense that it didn't have a clear beginning and a clear endpoint. So I chose to start here. But as an example, as a scenario to start with, we're actually going to look at the Web 7.0 Trust Ecosystem meta model. And that we're going to visualize or document using DIDComm notation. And based on that meta model, we're going to create a specific scenario, specific examples of issuers and verifiers and trust ecosystems of different kinds of methods and different kinds of DID registries and that sort of thing, and how this all comes together to build or represent a trust ecosystem. And one of the things that we're going to introduce here is the concept of relationship elements within a DID document. It's a generalization that can be used to enable DID documents to represent arbitrary collections of type relationships, and hence it enables us to use DID documents to encode or to represent any trust ecosystem. In section 2, we're going to look at some specific examples, some specific JSON DID documents where we encode these trust relationships within a trust ecosystem. We refer to these documents as trust registration documents based on DID document notation. And finally, we're going to kind of bring things together a little bit with the concept of an ecosystem of ecosystems of ecosystems, Decentralized Digital Governance Model, or DDGM. As we work through this aspect of the Web 7.0 Trust Ecosystem Framework, we found another generalization. the concept of decentralized graphs, the idea that we can have decentralized data with decentralized control over the data. And finally, in Appendix A, we're going to look at 101, begin to look at 101 novel applications of DID document technology. So just extracting, again, some of the key concepts, because again, this is kind of a bit of a complex talk. Let's get some of the nomenclature kind of in our minds. So the idea of there being trust registry documents or trust registration documents represented using DID documents. The ability to represent arbitrary collections of typed relationships using DID documents. And we have the general purpose relationship element that can then help support us. This is an addition or extension to the DID core. In addition, we needed a way to label individual methods, DID methods, and trust ecosystems, in addition to just the entities themselves. There's the concept of ecosystems, which I've talked about and that we'll go into deeper. The Decentralized Digital Governance Model, or DDGM. And then this novel concept of decentralized graphs, the idea of having decentralized data with decentralized control over the data. And then we'll look at Appendix A, this concept of 101 uses for DID documents, and we'll look at a couple kind of unrelated applications of DID document technology, separate from the DID registry application. Okay, so let's look at how we represent arbitrary collections of typed relationships using DID documents. And we'll start by looking at the Web 7.0 trust ecosystem. So there's a number of different elements to the model, so let's just kind of go over them. Again, these are representing using DIDComm notation. So in the top left-hand corner, we have Alice. For all intents and purposes, let's assume Alice is a real person. Alice has a personification. She has a representation, or in DID core terminology, she's a subject. And so Alice's personification is identified by a DID. In this case, DID person 1, 2, 3, 4. Separate from Alice's personification, she might also have a trusted personal agent, a software agent that can act on her behalf. Allison's trusted personal agent is identified or known or labeled by its URL, by the URL of its default service endpoint. So in this case, that's http://example.com:8080. And additionally, or optionally, Alice's trusted personal agent may make use of a wallet, a digital wallet. And so here we see Allison's wallet, and we see that the DID here is not a unique DID for the wallet per se, but it's identifying that this wallet is an instance of a particular wallet implementation, which will become more obvious once we start talking about a particular trust ecosystem. Okay, so here we see the province of Savronia.ca trust ecosystem, and in DIDComm notation, we represent that as an octagon, and we can see that the province of Savronia.ca trust ecosystem has a DID:CA:savronia. Savronia is a fictitious province in Canada, and the :1 means that this is a trust ecosystem. This is one of the extensions that we've added to the DID core spec for Web 7.0. And when we think of that trust ecosystem, we can see that, it has the obvious things in it. It has an issuer, the ICANN issuer, the verifier. It has a DID registry, and depending on the implementation details you use for your trust ecosystem, it may or may not have a verifiable data register, and we see that visualized or illustrated at the bottom. And so if we bring all of this together, we have Allison's personifications and the DID methods that those personifications may be part of. We've got trusted personal agents and their implementations. We have wallets and their implementations, issuers, verifiers, registries. So this is really starting to flesh out at a meta model level, at an abstract level, what a trust ecosystem looks like. And we can continue to evolve that and choose a representation for that as we work through the rest of this. So each one of those blue lines is actually a relationship. It's a relationship between the province of Severonia.ca trust ecosystem, the DID:CA:/Severonia:1, and each of these items identified by their DIDs. So the question, or one of the primary goals then for this talk, is how to best represent an arbitrary collection of relationships using DID documents, because if we can achieve that goal, then we know how to create or encode or represent trust ecosystems using DID documents as well. So let's take that meta model that we just looked at and create a more specific or concrete, a more specific example, a more concrete example. So here we still have Alice, the real person, up in the top left-hand corner. But in the second column, you can see that Alice has, in this case, 4 different personifications. There's Alice Allison, DID:person:1, 2, 3, 4. There's Alice Gamer, Alice Athlete, and Alice Chef. Each one of those personas has its own DID, as you'd expect, and each one of those DIDs belongs to a different DID method space. And in the sort of the third column, the trust ecosystem column, we can see that there's 2 ecosystems, the province of Severonia.ca trust ecosystem and the professionals trust ecosystem. And we can see that Alice Allison, DID:person:1, 2, 3, 4 belongs or is part of or is an accepted part of the province of Severonia.ca trust ecosystem. And we can see that the other 3 personas from their respective methods are part of the professionals trust ecosystem. And we see 2 examples where we've labeled the blue arrows. We can see that the relationship between Alice Gamer and the professionals trust ecosystem is identified as a methods accepted relationship. So in the professionals trust ecosystem, hopefully we see something that represents that relationship, and hopefully it's typed as methods accepted. Between Alice Allison in the top left-hand corner and the ICANN issuer, we can see a relationship between those 2, which is issuers accepted. So that's saying that in the DID:person method space, there's an issuers accepted relationship that identifies the ICANN issuer, DID:/or:111 as an accepted issuer in that DID:person method space. And so there isn't really just one ecosystem here. There's the trust ecosystems in the octagon-shaped DID notation symbols, but we actually find that there's a series of an overlapping fabric of ecosystems, and that's just a hint to something we're going to see a little bit later on. Okay, so to represent all of those relationships, we needed some extensions. We had some additional requirements to the DID core specification. So the total set of requirements here, and this is primarily focused on DID identifiers. The first one, an entity needs to be identified by DID. Well, that's baked into the DID core. A DID method needs to be identifiable by DID. This was discussed during the development of the DID core specification, but it never made it into the specification. We differentiate between DID methods, the method itself, like DID:person, and the DID method ecosystem that method is a part of. So we need identifiers for both, and we'll see examples in a moment. Trust ecosystems also need to have their own type of identifier. And without creating new method spaces or without creating a centralized method space for the trust ecosystem identifiers. And so we'll show an approach that we recommend for that, which is a natural extension of how we encode DID method ecosystems. Finally, each of the different kinds of foundation services in the Web 7.0 trust spanning layer protocol framework needs to be identifiable. Those are all entities, so that's straightforward. But they also, each one of them represents an ecosystem. And so we need a notation. We need to extend the notation we use in 3 and 4 to be able to refer to all classes of objects and be able to specify the relationships between any given object in an ecosystem and all of the surrounding elements that it is related to. And we need to do this in a decentralized fashion. So this is giving rise to our decentralized graph concept and the fact that we're going to have decentralized data, decentralized subgraphs that are with decentralized control over the data in those graphs. And by natural extension, we have different kinds of trusted personal agents in the ecosystem framework, user agents, storage agents, and many other types of agents. So we'll see examples of these. So here we can see an entity that's identifiable by a DID. So on the left, we can see DID person 1, 2, 3, 4. That's just a standard DID document. The only piece of novelty is at the bottom in lines 26 to 30, where we can see that this is actually a load balance, round robin load balance service endpoint. We'll talk a little bit about that when we get to Appendix A. On the right-hand side, we see basically the same DID document for DID person 1, 2, 3, 4, but it's a little bit different. It has all the elements of the DID document on the left, but it also has a relationship element starting in line 30. And this is just showing in a bit of an abstract way the way that we can take the service endpoint defined in line 18 and 18 to 28, 29, and how we can encode that using the relationship element. This is the new element that we're proposing to support arbitrary collections of typed relationships in DID documents. So we can see that it's essentially the same, but if we look in line 33, we see that the type includes the tag service. So instead of in line 21 having default load balance round robin, we now see service default load balance round robin. The point being here is that relationships are a generalized concept that can be used to encode the type of an arbitrary number of relationships related to the subject of a particular DID document. So this is saying that DID person 1, 2, 3, 4 has a service relationship, a service load balanced round robin relationship with those endpoints that appear in 35 through 38. We need a way to identify an individual DID method using a DID. So in the discussions that weren't accepted during the development of the DID core, it was suggested that a notation like DID person 0 could be used to identify the DID method. And in effect, it makes the ID string 0 unique and like a unique and special keyword in the DID core and DID resolution terminology. So we can see DID person 0 refers to the actual DID method DID person, and not just as documentation, but as a further interpretation, we've included the purpose element immediately below the ID that says this is a trust registration document for a method. So this is a trust registration for a method, and the method that it refers to, DID:person, identified by the identifier DID:person:0. And if we look down at line 31, because this is a trust registration, a method trust registration document, we see relationships are being used to define the place, this method's place within another ecosystem. So if we look at line 35, we look at the type of the relationship. It's ecosystems accepted. So DID:person:0 accepts to be a part of the following ecosystems. And if we look in line 37, we see DID:person:1, and we see DID:CA:/Soveronia:1. And so this is saying, first of all, that those :1, the DID:person:1 and DID:CA:/Soveronia:1, those are, by definition, ecosystem identifiers because they have the :1. We haven't really seen that yet. And that those are accepted ecosystems by which DID:person, the DID:person method agrees to be a part of. So in respect, this trust registration document, this method level trust registration document, supersedes the registry work that's happening in the W3C. Let's move on. Okay, so how do we represent a DID method ecosystem? How do we identify a DID method ecosystem using a DID? So right at the very top in line 2, we see DID:person:1. So previously, DID:person:0 referred to the method. DID:person:1 refers to the ecosystem. So previously, when we said DID:person:0 belongs to or accepts to be a part of the DID:person:1 trust ecosystem, we're saying that DID:person:0, the method, agrees to be part of this ecosystem as illustrated here and as defined by these three relationships. So we can see the first relationship is methods accepted in line 35. So we're saying that DID:person:1, this ecosystem level concept, accepts the following methods: DID:person:0. So we now have a bidirectional transitive relationship between DID:person:0 and DID:person:1. This is important. We'll talk about it later. The second relationship in line 41, what issuers are accepted into this ecosystem? And we see DID::org:111. If you look on the left, DID::org:111 is one of the issuers that can issue DID::person identifiers. Similarly, in line 49, we see the ecosystem verifiers, the method ecosystem verifiers that are accepted by this DID::person:1 method ecosystem. And we can see that it's DID::org:444 and DID::org:666. Going into the bottom half of that same DID document, we see, again, a whole series of relationships that are defining how DID::person:1, that method ecosystem, agrees to interact with its surrounding counterparts. Line 51, the verifiers that are accepted. Line 59, the VDRs that are accepted. 67, the ecosystems that are accepted. Now, this is interesting. We're talking about DID::person:1, which is a method ecosystem. And we're saying that DID::person:1 agrees to be part of the DID::CA:/Soveronia:1 trust ecosystem. This is our first example that gives rise to the idea of having ecosystems of ecosystems. Line 75, the wallet implementations that are accepted. Line 83, the roles that are accepted. Here, I got a little bit lazy and I was running out of space on the slide, so I just said star, saying we accept all roles. But that could be, again, an array of DIDs that identify a particular set of roles. And they don't have to be DIDs, they can be arbitrary URIs. And then credential defs accepted down in line 93. So we have a fairly, between the top half and the bottom half of this trust registration document, we can see that we've got a fairly rich description of an ecosystem from the perspective of an individual DID method. Let's look again. Let's move on. Here, we're now looking at a trust ecosystem, DID:CA:/Soveronia:1. And I've copied the example scenario onto the left hand of this slide. So if you see in that top octagon, we've got province of Soveronia.ca, trust ecosystem, DID:CA:/Soveronia:1. And although I've chopped off the top 27 lines of this trust registration document, it is the trust registration document for DID:CA:/Soveronia:1. And we can see all the different relationships actually represented by the blue lines on the left-hand side that are encoded in this trust registration document. We can see the methods that are accepted, DID::person:1. We can see the issuers that are accepted. It's the ICANN issuer, DID::org:111. We can see the verifiers that are accepted. In this case, it's two. It's DID::org:4444 and DID::org:6666, the very verifier and the very verifier. The VDRs that are accepted. The wallet implementations that are accepted. In line 66, the DID registries that are accepted. And then, of course, we have the roles, the wildcard for the roles accepted and the credentials accepted. So we can see here, we can create very rich, arbitrarily rich descriptions of trust ecosystems using this concept of being able to represent arbitrary collections of typed relationships in a DID document. We also see highlighted in line 33 the fact that this concept of ecosystems. So this is the trust ecosystem for DID::CA:/Soveronia:1 or :1, and it is saying that the accepted methods are going to be defined as DID::person:1. It's saying that the accepted methods are the DID::person:1 ecosystem. So then we can go to that DID document for that ecosystem and find out what is important, what is acceptable, what is trusted within the person DID::person ecosystem. I'll have a better visualization of this in a moment. I realize it's a little bit kind of like a Mobius strip folding back on itself. I didn't create any examples here, but I'm just highlighting that issuers and verifiers, VDRs, DID agent registries, and DIDComm network message router agents are all part of the of a trust ecosystem, and they in turn are defined by their own ecosystems, just as we saw for the DID::method ecosystem. The previous slide looked at the trust foundation services that are part of the Web 7.0 trust spanning layer framework. The lowest layer in the trust spanning layer protocol framework. The upper layer, of course, is the trusted personal agents. And so this is highlighting, the user agents and the storage agents that are at that trusted personal agent layer. Let's talk about the equivalence of the DID document service elements and relationship elements. I've kind of highlighted this before, but let me just give a little deeper example, if you will. So in the top half here, from line 20 to line 32, you can see there's a service element. This is a slightly different service element. It's one that provides load balanced round robin support for high availability within a decentralized ecosystem. And then in the bottom half, from 33 to 45, we see a relationship element. The top half, the service element, and the relationship element on the bottom are exactly equivalent to one another. It's highlighting that relationships is a generalization over other types of elements within the DID document syntax. So in line 37, we can see that this relationship is a specific type of relationship. It's a service relationship, and that it has subtypes default, load balanced, and round robin. Default, load balanced, and round robin happen to be the exact same types that appear in line 24 of the service element. So relationships are a generalization of service elements, and as a generalization, relationships can be used to represent arbitrary collections of type relationships in any DID document. And hopefully over the fullness of time, relationship elements become the dominant type of relationships, the generalization within DID documents, and without having to see an ongoing need to expand all kinds of specific elements like the service element. So let's look at some trust registration document examples we've already seen. So this is DID : person : 0. So this is again, just kind of reviewing a bit, this is a trust registration document for a method. DID : person is a method. 0 says that this is a trust relationship, a trust registration document for a method. And that it is, down in the relationship section, it can be accepted into different ecosystems, DID : person : 1, and DID : person, or DID : CA : Serodia : 1, like we've seen before. So DID methods can have service endpoints. It might not be practical, but we're supporting that general case where method DID documents can have service endpoints. That's maybe not typically the case, but in the blue box, being able to have a relationship to a higher level ecosystem does make sense. Here we're looking again at DID : CA : Seronia : 1. This is the : 1 means it's a trust registration document at the ecosystem level. And we can see in the relationship that we have methods accepted and issuers accepted corresponding to the diagram. We have verifiers, we have VDRs, wallets, registries, roles, and credential defs. To make this change to support the new relationship element in Web 7.0 was not very difficult because we define all of our objects using an abstract notation and code generation system. So here we can see how a DID document is described, referencing directly out of the DID core, the DID document properties section. We have IDs and comments and context and controller and all the different kinds of verification method maps. And then at the bottom there, we have a service element, and it's defined as a service map. And we can see that the service map is defined up here at the top. That's how DID documents are defined today. In Web 7.0, we made a small change. We added a relationship element, which is also of type service map. We didn't want to kind of redefine the whole world. We wanted to make the minimal number of changes as we could. So we just said a relationship is also a list of service maps. So a service map is defined here at the top. And so, the list of issuers, the list of verifiers, the list of trust ecosystems that we choose to be a part of. I am defining those as service endpoints as a list of strings, as a list of URIs. So the nomenclature is a little bit off, but again, this represents a minimal way of making changes simply by reusing the service map construct to also define relationships. So let's get to the ecosystems of ecosystems discussion, the decentralized digital governance model. And I've noted this already wherever we've had the opportunity. So here we have a person method. So this is a person method defined by :0. And we can see that that method in purple here can be part of certain ecosystems that it has chosen to be accepted into. So did:person:0, the method, can be accepted into the did:person:1 method ecosystem and into the did::ca::Savronia:1 trust ecosystem. Here we can see the did::person:1 method ecosystem, and it has certain relationships. Here's the top half of the relationships, and here's the bottom half of the relationships. If we look at line 37, we can see that did::person:1 accepts did::person:0, that method, as a method that's acceptable in this method ecosystem. There's verifiers, the VDRs. In essence, these trust registration documents actually become configuration documents. You can imagine verifiers and issuers, for example, being written in the most general sense. And how do they know which VDR to use? They look it up in the appropriate trust registration document. When a trust ecosystem is being spun up, how does it know which issuers are part of its ecosystem? How does it know which DID registry is part of its ecosystem? How does it know anything about itself? It goes and asks itself by looking at the trust ecosystem, trust registration document. Here we've moved up to kind of the third level. So this is an ecosystem trust registration document. And it's telling us about did::ca::Savronia:1. It accepts certain methods, did::person:1, i.e. did::person:1 at the method ecosystem level. There's different issuers, there's different verifiers, the VDR, the wallets that are accepted. This is exactly what I just spoke to a moment ago. This is the configuration. This is the definition not only of a trust registry, but an entire system definition for the did::ca::Savronia trust ecosystem. So to visualize these a little bit different, and this is, again, the idea of visualizing things as ecosystems of ecosystems and ultimately leading to our visualization of a decentralized graph. We're going to start with the two ecosystems that we started with, the two trust ecosystems we started with, the province of Savronia.ca and the professionals trust ecosystem. And the first thing we're going to add in is just a person entity. Person 1, 2, 3, 4 from did::person the did::person method. Of course, this is Alice. This is Alice's personification. So Alice's personification, did::person: 1, 2, 3, 4, that's drawn from the person method space, did::person: 0. And that in terms gets its definition from did::person: 1, the person method ecosystem. And at this point, we know who the verifiers are. We know what, from the did::person: 1 person method ecosystem, we know who our verifiers are. We know who our issuers are. If there's a VDR at play, we know the VDR, and hence our issuers and verifiers know the VDR, etc. We have a fully defined ecosystem, just those three elements describing the different contexts for a person. We have issuers, and each issuer in of itself is an ecosystem because it's going to specify which VDRs it's capable of talking to, and potentially what trust ecosystems it's a part of. And each one of these ecosystems so far on the screen, these are all independent ecosystems. They're decentralized ecosystems. Each one of the DID documents describing each of those ecosystems is a decentralized graph. And you maybe see where we're starting to go with this. We have DID registry and its ecosystem, a verifiable data registry and its ecosystem. We have a couple of verifiers. Each one of those will have its ecosystem. It's like the friends and neighbors. It's like the other pieces of software it knows how to play with. And we actually begin to think of each of these, of the octagons in particular, each of the octagons as being ecosystems, and each one of them, the DID document, the trust registration document, a specialization of a DID document, ends up being a decentralized graph, a piece of distributed, disconnected data, decentralized data that has decentralized control over the data, because each DID document is going to have its own controller. You could have centralized control by specifying that the controller for every ecosystem points to the same identity, but the whole idea, what we're trying to support in the most general way, is decentralized data, decentralized graph data with decentralized control over the data. And so we can start to draw in some of the relationships. So we can see that a person entity knows that it's part of the person method. We can see that the person method is accepted as part of the person method ecosystem. We can see that the person method ecosystem is part of the province of Sovronia CA trust ecosystem. We can see that all the Sovronia.ca ecosystem accepts all of these other entities defined in the blue lines. The verifier ecosystem, the 4444 verifier ecosystem, the 4666 verifier ecosystem. And so each one of these octagons represents a trust ecosystem. Each trust ecosystem in turn is represented by a trust registration document, and a trust registration document in turn is a DID document. And each one of these is separate and independent unto themselves, each separate and independently controlled by its own controller. And so we end up with this concept of decentralized graph data with decentralized control over the data. So now if we start to look at sort of the overlapping relationships, what we're trying to highlight here is the idea of a decentralized graph. So in total, everything we see on this slide is a decentralized graph, or is a graph of relationships represented in a decentralized fashion with decentralized control over the data. And it begs the question then, how do we know what the effective set of relationships is for a given context. Let's say we're asking DID::org:111 to generate a person entity in the Subronia trust ecosystem. Well, that piece of software, the issuer, is going to have to look at what its capabilities are, what its relationships are. It's going to have to find out, does it have a relationship with DID::person? If it doesn't have a relationship with DID::person, the method, then it can't generate person DIDs. And even if it could generate person's DIDs, does it have a relationship with the Subronia.ca ecosystem? In return, does the Subronia.ca ecosystem have a reverse relationship back to the issuer? Does it accept the issuer? And so this gives rise to the idea of trust ecosystem contexts. And the way that we compute context by looking at the intersection. We look at the intersection of the relationships that an ecosystem has, for example, with a method, with an issuer, with a verifiable data registry, and potentially with a wallet implementation. And if we have something left in that intersection that we can work with, then we're able to issue a DID::person entity in the person method in the Subronia.ca ecosystem using a particular verifiable data registry, and we're able to deposit that into a particular wallet implementation. This is all done without any centralization. It's done by each decentralized graph defining its own relationships, perhaps with some out-of-band negotiation with its counterparts, but it defines what it is willing to accept and what it's willing to participate in, as are all of its colleagues in the trust universe. And when we find intersections, then we're able to do business with each other. We're able to, an issuer is able to generate an entity within a particular method space into a particular ecosystem that's storable in a particular wallet. And we can do that with verifiers and with wallet implementations and everything else. So this kind of brings to the end. We're just going to go briefly into Appendix A next, but this brings us to the end of this concept of ecosystem of ecosystems and decentralized digital data governance. The fact that we can specify arbitrarily complex trust ecosystems and encode them as arbitrary collections of typed relationships and DID documents. So like I said at the beginning, the discussion is a little bit circular. Hopefully I've been able to connect all the different circles, all the different ecosystems together, and I hope you've enjoyed this talk. So briefly, let's look at other DID document applications. So the idea of using this is completely separate from the concept of trust ecosystems, largely separate from the concept of trust ecosystems, but we have high availability, fault tolerant, load balanced DDGM agent hosting model. So this is here on the graphic on the left, we have Alice's personification, and Allison's persona, her particular DID::person:123:4 persona could have 4 different instances, 4 different replicas of its agent running. And so we see those depicted in the blue box here. And so how do we encode that in a DID document? We encode it as a service element. And then we have the global DIDComm network message routing data. This we haven't alluded to at all, but we have talked briefly about DIDComm network message router agents, and they need to know who their nearest relationships are, who their nearest neighbors are. And so we can see here that there's a DID::node:201, and it has relationships with node 3, node 5, and node 7. It also knows that it's the nearest neighbor node to DID::person:123's trusted personal agent at the bottom. So the key concepts we just to review and closing up here, to summarize, we've talked about trust registration documents being represented using DID documents. The ability to represent arbitrarily collections of typed relationships using DID documents and using the general purpose relationship element to do that. We've talked about some extensions to DID core for supporting DID identifiers for labeling methods and ecosystems and method ecosystems and trust ecosystems. The concept of ecosystems where they can be interreferential with respect to one another. The concept of a decentralized digital governance model where each trust ecosystem is able to declare the relationships that are meaningful in its context, and it's the intersection of those relationships that actually defines the the trust registration context that we talked about before. And kind of an interesting side benefit is we've been able to identify and define this concept of decentralized graphs, decentralized graph data with decentralized control over the data. And then we've talked about a couple of different novel uses of DID documents, pretty much unrelated to this talk, but included for completeness. So I hope you've enjoyed this talk. It's gone on for about 50 minutes. If you have any questions, you can tweet them to Freddie Architect on Twitter, and Freddie will be sure to answer each and every question. And again, I thank you for your time. Enjoy the rest of your day.